Will there be a gold rush on Mars? We can't rule this out, but there are many factors to consider. Will there be a functioning interplanetary economy between Earth, Moon, Mars, and the asteroids? The goal of Elon Musk is to establish a permanent human presence on the planet Mars, where one man, even a driven and talented billionaire, and an extremely talented team, such a task is a tall order. This is not a criticism of the goal or the current means by which SpaceX plans to attain it, but an examination on a longer timeline. The first thing is getting there with enough cargo capacity to make a real go of it. Such is the genius of the Starship project. In the podcast called Settling Mars, a few steps needed for gaining a foothold on the red planet were outlined. The question arises, however, as to how truly self-sustaining settlement will survive and thrive. If the reusability and reliability of Starship follows the path of Falcon 9 and Falcon Heavy, then the settlement of Mars is promising indeed. I use the word settlement very specifically rather than colonization. This word has all the wrong connotations as it implies subservience or obedience. My personal wish is for the establishment of a strong, independent community on both Mars and the Moon. From our experience here on Earth, we need also remember how economics is used to control people or for self-defense. Initially, Mars settlements will be highly dependent on Earth. How long will it take to establish the most basic infrastructure? How long before the processing of raw materials before manufacturing can even begin? Preliminary surveys, it would seem, have established that most, if not all, of the materials are present on the Moon and Mars for supporting life. However, without life already present, or the geological and hydrological processes available on Earth, pioneers will truly be starting from scratch. As stated in a previous podcast, it is my opinion that the Valles Marineris shows the most promise for establishing the first Martian cities. Comprising many of the lowest areas on Mars, the temperature extremes there will be somewhat less. A bit of extra atmosphere also provides additional radiation protection. As it appears, there was once liquid water on the surface. This vast canyon is likely the result of massive flows in the past. For this reason, it is likely that concentrations of heavier elements such as gold, platinum, silver, palladium, and other precious metals have been deposited there eons ago. Even without water, the scant carbon dioxide winds continue adding to alluvial flows at many points along the perimeter. Processed platinum group and other rare metals are currently worth more than gold, depending upon availability and the facility to process them. They could be the first interplanetary commodities. It is a matter of the price per kilogram of mining, refining, and launching from Mars and the ease of delivery. As Mars is untouched by human activity, the first quantities of these materials could be easily accessible near the surface. SpaceX is taking great leaps toward reducing that cost per kilogram for getting payloads into space. In terms of fuel and thrust, it will take considerably less to launch from a planet with 38% of our gravity. Sending a couple of tons of platinum from Mars could be extremely cheap, as could recovery be on Earth. As described in one of my sci-fi novels, dry panning in the vast alluvial deposits of the Valles Marineris may yield the first pay dirt from our nearest neighbor. As in a river, the heaviest elements sink to the bottom of a shaken container while the lighter constituents are removed by means other than water. On Earth, the excess is blown free or vacuumed up, so some creativity will be required for Mars. Settlers must find ways of extracting Martian resources in the most efficient manner to recoup such large investments. Mars may prove to be the least costly place for extraterrestrial mining for some time. Finding mineral deposits on the Moon could be considerably more difficult without that initial sorting done on Mars by water or volcanic activity. It will take time for geologists on both worlds to work out the most profitable points to begin. For both local economies, metals such as iron, aluminum, magnesium, etc., will still be in great demand. Those materials are needed to build habitats and local processing facilities with investment supplied from Earth. Liquid fluoride thorium reactors can provide vast amounts of energy required for smelting and the mixture of alloys. Focused sunlight could do the same for smaller operations. It's become a staple of movies and media to talk of harvesting helium-3 from the lunar surface. First of all, there are no practical fusion reactors and not likely to be any for some time. This is the only reason for mining helium-3, if it is in fact there at all. The most horrifying thought is how the rare isotope would be harvested. Granted, we need not worry about the impact of wildlife or lunar contamination, but such operations would deface our moon considerably. Helium-3 will all be in the surface layers and not in great concentration. Recovering it will entail scooping up loose regolith over vast areas before processing. The moon has no weather, so no way of washing away any changes we make to the surface. Strip mining helium would, over vast areas of the moon, wipe out features that have been there since before humans ever gazed in that direction. For those interested in space tourism, this is a definite no-no. Thorium is abundant on the moon, so fission reactors are just as practical as they are on Mars. Clean, safe power for the next several millennia is at our fingertips. Water, the most important substance for maintaining life, also has been detected in shallow deposits of the Valles Marineris. In the eastern Noctis Labyrinthus, there are signs of what was once a glacier. Water is essential for sustaining miners and a key ingredient for rocket fuels, whether they be methane, made by the Sabatier process, or pure hydrogen. A steady fuel supply is a must for interplanetary trade. By settling the moon and Mars, techniques and technologies will be developed to make living in space really living and not just existing. Shipping materials from the moon should be easier with gravity 1/6 that of Earth and less than half of that of Mars. Mars, however, has the great advantage of being more Earth-like as it turns only slightly slower. On the moon, there will be 2 weeks of darkness followed by 2 weeks of light, with greater temperature extremes. Psychologically, Mars should be preferable. With careful adjustments, humans may partially adapt their circadian rhythm to that extra 39 minutes each day. It is important to note Mars' position with respect to the asteroid belt. Natural resources there could greatly benefit interplanetary commerce. It is believed that carbonaceous bodies are dominant there, with far fewer asteroids being rich in metals. Asteroid 16 Psyche is said to be worth from 700 to 10,000 quadrillion dollars in gold and other precious metals, but of course nobody knows. If NASA is successful in getting there, perhaps we'll see Ceres, a large asteroid between 2.5 and 2.9 astronomical units from the Sun, is believed to have a water ice volcano. Mars, with a significant population, may serve as a stepping stone to those resources. The asteroid belt is much higher in the gravity well than Mars or Earth. For this reason, the cost of sending those resources to the inner solar system will be relatively low, like rolling a ball downhill. Mining and processing operations may be on site in the belt, or raw materials could ship directly to the inner planets. Cargo ships would return empty or with goods from the inner planets. Water and other materials for fuel could be processed high in the gravity well and transferred to interplanetary tugs. In this way, the rocket problem could be greatly mitigated. That is, transfers between surface and space would largely comprise people rather than cargo. Goods manufactured and transported from materials in space would only require fuel to lower them to the surface. The angry astronaut has commented on the large number of refueling ships needed by the Starship to reach Mars or the Moon. What seems to have been missed is the fact that SpaceX has immediate plans on the table and NASA backing for their human landing system. Developing a fleet of workable space tankers is directly in line with their short and long-term goals. Of course, these are early days, but it seems obvious that SpaceX will be the first practical fuel supplier in space. There's no reason why their tankers could not be adapted to kerosene, liquid hydrogen, or argon transfers according to customer requirements. As oxygen may be the most abundant and easy to extract constituent on the moon, some tankers could supply only methane or hydrogen. They will be the standard oil of space. We keep hearing of experiments done on the ISS with respect to manufacturing in space, but thus far there's been no attempt to make any of them a reality. Supposedly, fiber optic glass of superior quality can be made in microgravity, and it is suggested that human organs may be grown more easily there. High-performance metal alloys for turbine blades or other specialty products may also benefit. Engineering of hypersonic transport is advancing quickly, so parts made from such materials may be introduced in these new industries. Additive manufacturing is making great strides as well and may be very adaptable to off-world processes. The first products to take off will need to be low-mass, high-priced items to make early efforts profitable. It could be that microgravity isn't even necessary for creating superior products, and lunar or Mars gravity is enough to make a few of them competitive. Other conditions may be the grounds for choosing those locations, such as manufacturing in vacuum on the moon or the thin CO2 atmosphere of Mars. Processes sensitive to oxidation may benefit from such environments. Another way for Mars or lunar manufacturing to be profitable is the increasingly ridiculous and onerous regulatory environment of Earth. Industries setting up on the red planet may all of a sudden be competitive as a result of nihilist politicians on the homeworld. Gone would be environmental assessments or worries about endangered species and habitats. Miners and manufacturers on Mars or the moon could finally dispense with governments completely. With resources and products in high enough demand, they could dictate their own terms. Regardless of Hollywood's utopian or dystopian scenarios, it is difficult to imagine space industry as a major part of Earth's infrastructure. Periodically, science fiction depicts either a garden Earth with all of that dirty manufacturing done in space, or a wrecked planet with only the elite living in orbit. Neither of these pictures is realistic, with 8 billion people on the planet and counting. At the same time, certain industries will be essential for interplanetary commerce of any kind to exist.